Okay, so for the last one, this video is going to be about subtopic 9.4, which is about chemical properties of carbonyl compounds. Carbonyl compounds, there are 5 chemical properties that you should know of. The first one is carbonyl compound ni dia boleh buat nucleophilic addition reaction. Yang kedua, dia boleh buat reduction reaction. Yang ketiga, dia boleh buat condensation reaction. Yang keempat is oxidation reaction. And lastly, carbonyl compounds dia boleh buat chemical test jenis iodoform test. Let's look at the first chemical properties of carbonyl compounds, which is nucleophilic addition of carbonyl compounds. Basically, if you have carbonyl compounds, tak kisahlah aldehyde ke, ketone ke, this is the functional group kan of the carbonyl compound, which we know functional group dia ialah C double bond O. Okay, you have to know C double bond O ni adalah electrophilic site. Okay, remember macam mana you nak tahu electrophilic ke nucleophilic site, boleh rujuk dekat my notes on ataupun my video dekat 4.1 ya. Okay, dekat chapter 4 ada terangkan nucleophilic site dengan electrophilic site. So basically kalau C double bond O ialah electrophilic site. So bila dia electrophilic site, dia akan bergabung, dia akan nak react dengan reagent yang jenis nucleophile. Okay. So kalau dia react dengan reagent jenis nucleophile, sebab itulah the type of chemical reaction yang dia boleh buat for the carbonyl compounds ni ialah nucleophilic addition reaction. Okay, sebab dia akan react dengan reagent nucleophile yang nucleophile. Okay, and kalau addition reaction, you should know addition tu maksudnya dia akan add dua benda, betul tak? Dia akan add dua benda. So bila dia add dua benda, okay, daripada double bond dia akan jadi single bond. Okay, so basically apa yang berlaku, this nucleophile dia akan melekat dekat this carbon. Bila dia melekat dekat this carbon, apa yang berlaku, C double bond O ni dia akan jadi single bond. Okay, dia akan jadi C single bond O. So instead of C double bond O, sebab dia addition reaction, dia akan jadi C single bond O, and dia akan add dua benda. Dia akan add dua benda tu kat mana? Dekat carbon. Okay, dia akan add di carbon. And also dia akan add dekat this oxygen. Okay, ini adalah site yang akan responsible in the addition reaction of the carbonyl compounds. Dekat carbon, satu dia akan add dekat carbon, satu dia akan add dekat oxygen. Okay, and the carbon ni dia akan jadi site for the nucleophilic attack. Okay, jangan risau, you tak perlu pun belajar mechanism, you just need to know je how benda ni berlaku. Okay, sebab itulah bila dia buat nucleophilic attack ni daripada sp2 carbon, this is carbon sp2, dia akan jadi carbon sp3. Sebab itulah, that's why I told you, addition reaction you akan add dua benda. So that's why daripada C double bond O dia akan jadi C single bond O, and dia akan add dekat this carbon atom and also dekat this oxygen atom. Okay, for example, you can see this general reaction of the nucleophilic addition reaction of carbonyl compounds. If you ada carbonyl compounds, tak kisahlah aldehyde ke ketone ke, bila you buat sahaja nucleophilic addition reaction of this carbonyl compound, okay, with this reagent nucleophile, apa yang berlaku, kita akan add dekat kedua-dua ni, dekat this carbon and this oxygen atom. So daripada C double bond O, you can see dia akan jadi C single bond O. Because why? Because kita add dua benda. Kita add dekat carbon, kita add dekat oxygen. Okay, kat carbon ni dia akan dapat that nucleophile. Dekat oksigen ni dia akan dapat the hydrogen. Okay, sebab itulah daripada double bond dia jadi single bond. Alright, so basically carbonyl compounds dia akan undergo nucleophilic addition with some of these nucleophiles. Alright. Alright, so let's look at the first type of nucleophilic addition of carbonyl compounds, which is the addition with nucleophiles such as KCN ataupun NaCN followed by H2SO4. Alright, so tak kisahlah kalau you ada carbonyl compound such as aldehyde ke, ketone ke, and then kalau dia react with nucleophile such as KCN ataupun NaCN, in here basically the nucleophile yang kita gunakan adalah CN ya. This is what we are interested in. And then this is just additional reagent that needs to be paired with the nucleophile, NaCN atau KCN, which is H2SO4. So what you will get ialah cyanohydranes. Okay, so as previously I told you guys, bila you buat nucleophilic addition daripada double bond jadi single bond, and the site yang akan react with the nucleophile ialah C double bond O ni ya. Okay, so you have to focus at the C double bond O, because what happen at these carbonyls, okay, tak kisahlah dia aldehyde atau ketone, the carbon, okay, dia akan dapat the nucleophile tersebut. Alright, so if you see here, the carbon akan dapat the nucleophile. Okay, and then what happen to the oxygen, kita akan add hydrogen. Alright, dekat oxygen ni kita akan add hydrogen. So that's why lah daripada double bond jadi single bond. Faham? Let's look at these two examples. This is actually an aldehyde compound because C double bond OH, dan ini pula adalah ketone because C double bond O and dia diapit oleh dua alkyl group around 8. Okay, so basically bila dia react with either KCN H2SO4 ataupun NaCN H2SO4, so you need to know dia tengah nak buat nucleophilic addition reaction. So you have to know what kind of nucleophiles bila dia gunakan this kind of reagents. So the nucleophiles here adalah the CN, okay, because kita akan add the nucleophile ni kepada carbon, okay. Manakala site yang akan responsible for the nucleophilic addition reaction ialah this C double bond O, okay. C double bond O, and as you can see daripada C double bond O dia jadi C single bond O because kita buat addition, kita add dua benda, and at the carbon atom kita akan add the nucleophile, okay. Kat carbon ni kita akan add the nucleophile. In this case the nucleophile here adalah CN, okay. Manakala dekat oxygen ni kita akan add hydrogen atom, okay. So you boleh nampak lah ni adalah hasil masing-masing after kita buat nucleophilic addition with KCN ataupun NaCN and H2SO4. Alright, dari C single bond O. Lepas tu dekat sini you tengok the nucleophile CN is being added already, and dekat oxygen ni kita add the hydrogen atom. Same goes to this one. Dekat this carbon kita add the CN nucleophile. Okay, dekat this oxygen kita add the hydrogen atom, ya. Yeah? Alright, the second type of nucleophilic addition of carbonyl compounds is with addition dengan water and H+. Okay, di mana kat sini kalau you ada carbonyls such as aldehyde or ketone that is reacted with this reagent such as H2O dengan H+, okay, kat sini dia punya nucleophile adalah OH. Okay, so you kena kenal pasti nucleophile tersebut because dekat this carbon you memang akan add the nucleophile tersebut. Dekat oxygen ni you tambah hydrogen sahaja, okay. So you boleh tengoklah kat sini the site yang terlibat adalah the C double bond O. That's why sebab dia adalah addition reaction kan, daripada double bond O jadi C single bond O. And dekat carbon ni memang kita akan add the nucleophile, okay. Lepas tu dekat oxygen ni kita akan just add hydrogen. Alright. So you kena kenal pasti nucleophile apa yang dia add tersebut. Kalau dia gunakan this reagent, the nucleophile yang dia add adalah this OH, and then dekat oxygen ni dia just terima the hydrogen. Alright. Sebab itulah kita akan dapat compound yang germ diols, okay, because kita ada OH macam tu. Okay, for example, you can see here, this is actually an aldehyde. Is part of the carbonyl compounds. C double bond OH ni adalah aldehyde lah ni. So sekarang ni bila you nampak sahaja dia react dengan H2O dengan H+, that means dia tengah buat nucleophilic addition. Therefore daripada C double bond O kita akan dapat C single bond O, and at the carbon atom we will add the nucleophile. In this case the nucleophile adalah OH, and also dekat oxygen ni kita akan add hydrogen atom sahaja, ya. Okay, so the second example you can see here, this is actually a ketone. Bila dia react dengan reagent H2OH+, okay, as usual, this dia tengah buat nucleophilic addition reaction. So daripada C double bond O jadi C single bond O. Another carbon atom, dia akan add the nucleophile, add the oxygen, dia akan add hydrogen. Okay, so this is how it goes. Okay, the next step of nucleophilic addition of carbonyl compounds adalah dengan alkohol. Okay, walaupun dia punya reagent adalah alkohol, dia kena react with apa tu H+. Tetapi tak kisahlah dia aldehyde ke ketone ke, you kena tahu apakah dia punya nucleophile alkohol ni. Okay, it's not OH. Kalau H2O tadi, yes, OH. Tapi in this case, kalau alkohol, dia adalah OR. Okay, OR prime. R prime ni adalah alkyl. Alkyl group, any alkyl group. It can be CH3, CH2, CH3, okay. Tapinya, tak kisahlah dia aldehyde ke ketone. Bila dah cakap buat nucleophilic addition reaction, daripada C double bond O, dia akan jadi C single bond O. Okay, and you need to know, dekat carbon ni kita akan add the nucleophile. Okay, the nucleophile dekat alkohol ni bukan OH tetapi OR prime ataupun O alkyl group. Same goes to the ketone as well. OR prime. Okay, bukan OH. So you kena kenal pasti. Once you kenal pasti dia punya nucleophile, it will make your life easier when you do this. Okay, and then dekat oxygen ni, as what I told you, kita akan add hydrogen. Okay, so basically as you can see here, aldehyde bila dia buat nucleophilic addition dengan alcohol, in the presence of the H+, dia akan dapat hemiacetal organic compound. This is actually a hemiacetal. Okay, di mana COH and then OR. OR ni adalah alkyl group. Manakala ketone pula, bila dia buat nucleophilic addition dengan alkohol, dia akan dapat nama dia hemiacetal organic compound. Okay, tapi kalau kita reactkan further hemiacetal ke with alcohol in the presence of H+, apa yang akan berlaku adalah, okay, daripada H ni kita just tukar kepada alkyl group sahaja. Okay, so H ni dia akan switch dengan this dengan alkyl group of the alcohol yang dia react further. So kalau untuk hemiacetal, okay, this is hemiacetal. Bila dia react further dengan alcohol in the presence of H+, site yang akan terlibat untuk buat this kind of reaction adalah H. So H ni you just tukar dengan this R prime. Okay, so R prime ni ada kat situ. Okay, same goes to the hemiacetal if you react further with alcohol in the presence of H+. So H ni you just gantikan dengan alkyl group of the alcohol. You got it? So apa yang berlaku bila hemiacetal dia react further with the alcohol, kita akan gantikan H ni dengan alkyl group of the OH. This is what we call it as acetal. Kita jangan kacau apa-apa, kita kacau this one saja. Okay, kalau let's say hemiacetal pula dia react further with the alcohol, okay, apa yang berlaku kat sini, H ni kita gantikan saja dengan alkyl group of the alcohol yang dia react with, and then dia akan form ketal. Okay, so let's look at this example. Kalau you ada carbonyl compound, in this case is a ketone, they react dengan alcohol in the presence of H+, as what I told you, you need to identify what kind of nucleophile yang dia akan add kepada this carbon atom. Kalau alcohol is not OH as dia punya nucleophile, it is the RO. This is the alkyl group yang attached kepada this OH. Okay, so RO. So you need to know the nucleophile here adalah RO ni. R ni adalah alkyl group. O ni adalah oxygen of the alcohol lah. Okay, so basically apa yang akan berlaku ialah kita akan add dekat this carbon atom OR kan. Dia punya general chemical reaction in the previous slide adalah OR, di mana R kat sini adalah CH3. Okay, so it will be OCH3 lah. Dekat oksigen ni kita akan just add hydrogen atom. Okay, so that's why bila dia buat nucleophilic addition with this alcohol, this type of alcohol which is methanol in the presence of H+, okay, dia buat nucleophilic addition, therefore you can see daripada C double bond O, dia akan jadi C single bond O. And at the carbon atom, kita akan add dia punya nucleophile yang kat sini ni, which is OCH3, and then dekat oxygen kita akan just add the hydrogen atom as you can see here. Alright, this is the nucleophile, and then this is the hydrogen. So ini adalah organic compound yang kita namakan dia sebagai hemiketal. Okay, because this is a ketone. So bila dia buat nucleophilic addition with alcohol in the presence of H+, dia akan menghasilkan organic compound yang dinamakan sebagai hemiketal. Okay, yang lain you salin balik saja, because the only site yang akan responsible for the nucleophilic addition reaction ialah C double bond O. So dari C double bond O dia single bond O. Yang ni you salin balik je. Okay, so what if they react further with alcohol in the presence of H+, as what I told you, dia akan, kalau let's say daripada hemiketal, dia akan jadi ketal. Okay, di mana kat sini yang lain semua stays the same, cumanya hydrogen ni kita akan substitutekan dia bersama the alkyl group of the alcohol ni. Alright, so this is the alkyl group. Kalau if you look at the previous slides, okay, dia gantikan H dengan R prime kan. Ini adalah R prime prime. Because this is the second alcohol yang dia react with. So basically daripada H ni, dia just gantikan dengan R prime prime. In this case ialah the alkyl group yang attach pada OH ni adalah CH3. So you gantikan saja H dengan CH3, di mana ini adalah rupa bentuk ketal, organic compound. Alright. Next nucleophilic addition of carbonyl compounds adalah dengan addition with sodium bisulphate, which is NaHSO3. Again, bila you nak buat nucleophilic addition of carbonyl compounds, tak kisah reagent apa-apa, you have to know what kind of nucleophiles dekat reagent tu yang akan di-add kepada carbon of the carbon double bond O. In this case, okay, dia punya nucleophile adalah SO3 minus Na+. Okay, so this is the nucleophile of the sodium bisulphate. Okay, kiranya dekat this carbon kita akan add SO3 minus Na+, okay, yang dikenali sebagai bisulphate salt. Okay, dekat oksigen ni kita just add hydrogen atom sahaja ya. Okay, so you can look at these examples. This is actually a ketone and this is aldehyde. Okay, bila dia buat nucleophilic addition with sodium bisulphate, NaHSO3, what happened here daripada C double bond O, okay, dia akan jadi C single bond O. Okay, dekat oksigen ni, as usual, we know kita akan just add the hydrogen atom, and at the carbon kita akan add the nucleophile yang terlibat. In this case, the nucleophile adalah SO3 minus Na+. Okay, as simple as that. Alright, so the last step nucleophilic addition of carbonyl compounds adalah dengan Grignard reagent. I believe that this is not something new to you because you have learned this at Chapter 8, alcohol. Okay, so ni macam nak refresh your memory saja, and also I would just want to make some updates here because previously I think I haven't updated my slides and with the schema right now. They actually wants you to draw yang kalau let's say followed by hydrolysis tu atas arrow. Okay, jangan buat bawah arrow. This is the new schema, new standardization on how to write the chemical reaction kalau dia ada kata followed by hydrolysis. And also, okay, hydrolysis right now, hydrolysis dia tak guna dah H3O+, ya. Dia guna H2OH+. So you can see here, bila dia kata followed by hydrolysis, it's H2OH+. Kalau hydrolysis je, you need to remember H2OH+. That is untuk hydrolysis lah, bukan H3O+, ya. H3O+ ni sekarang ni dia adalah weak acid. And also you need to remember, letak 1 dengan 2 ni atas arrow, jangan buat bawah arrow. This is the updated one. Okay, so I hope that you can, kalau you tengok my video ni, you boleh stay alert on this lah. And then I hope that you boleh buat pembetulan untuk my slide on the chapter 8 alcohol tu. You just bawa H2OH+ tu naik atas. Kalau if I wrote H3O+, please betulkan dengan H2OH+, ya. Okay, tapi dia punya sama saja. Kalau Grignard reagent, kita buat nucleophilic addition with carbonyl compounds such as aldehyde atau ketone followed by hydrolysis, okay, kita akan dapat alkohol. Itu je. Kita akan dapat ketiga-tiga ni dapat alkohol. Cumanya it depends on the type of carbonyl yang digunakan. Okay, kalau kita gunakan methanol like this, kita akan dapat primary alcohol. Okay, we will get a primary alcohol. And then kalau kita gunakan any aldehyde selain daripada methanol, kita akan dapat produknya ialah secondary alcohol. And lastly, kalau kita gunakan ketone yang react dengan Grignard reagent followed by hydrolysis, we will get a tertiary alcohol. Okay, cumanya kat sini, I just want you to take note of how they write down dia punya chemical reaction ni. Sahajalah yang ada perubahan. Dia punya dari segi produk tu sama sahaja, ya. So please take note of this. Okay, selain daripada nucleophilic addition reaction of carbonyl compounds, the other chemical properties of carbonyl compounds adalah reduction reaction. So kiranya carbonyl compounds dia boleh buat reduction reactions, tetapi you kena tahu, okay, kalau let's say aldehyde, dia buat reduction reactions, dia akan reduce kepada primary alcohol. Kalau ketones dia buat reduction reactions, dia akan reduce kepada secondary alcohol. And you need to know the common reducing agents. Okay, this is the symbol for reducing agents. Dalam kurungan tajam macam ni, H. Kalau let's say dalam kurungan O ni, this is actually oxidizing agents, and we have learned some of the common oxidizing agents. Okay, but right now I want you to know the common reducing agents bila you nak buat reduction reactions are as followed. Okay, sama ada you boleh gunakan liau, orang panggil ni liau lah, lithium aluminium tetrahydride followed by hydrolysis H2OH+. Ataupun you boleh gunakan NaBH4 in the presence of methanol. Okay, yang ni kalau let's say orang nak senangkan, orang panggil Nabiha, macam tu. Sebab macam, I don't know lah, it's up to you lah macam mana you nak hafal kan. And lastly, the common reducing agents yang senang juga adalah catalytic hydrogenation, di mana kita akan gunakan hydrogen in the presence of catalysts such as platinum ataupun nickel. Okay, so if you see any of these common reducing agents, maksudnya your carbonyl compounds tengah undergoes reduction reaction. So apa yang berlaku bila you buat reduction reactions ni? Okay, bila you buat reduction reactions ni, it is as if kalau oxidizing agent, kita akan macam buang dua hydrogen. Okay, tapi bila kita buat reduction reactions ni, it is as if we add 2 hydrogen. Okay, Kalau tak cari, boleh tengok ni sama ada aldehyde atau ketone. Okay. So this is it, the C double bond O. Okay. So what happen here is dekat carbon ni kita akan add hydrogen. Dekat oksigen ni pun kita akan add hydrogen. Okay, same goes to the ketone. Dekat carbon ni kita akan add hydrogen. Dekat oksigen ni pun kita akan add hydrogen. Okay. So, kalau you tengok this is aldehyde kan, pada asalnya C double bond OH. Bila dia react with the reducing agent such as Lial, LiALH4 followed by hydrolysis. As you can see here, I already corrected the version of the standardization on writing the chemical formula. Di mana kalau dia kata ada followed by, yang nombor 2 ni pun kena letak atas arrow. Macam tu. And then hydrolysis is H2OH+. Okay, what will happen here is bila aldehyde you jumpa dia buat dengan one of the common reducing agents such as this, dia akan dapat primary alcohol. Okay, tak kisahlah dia guna Lial ke, dia guna Nabihah ke, dia guna catalytic hydrogenation ke. As long as dia aldehyde, you akan dapat alkohol. So, you boleh nampak lah dekat sini daripada C double bond O, dia jadi C single bond O. And as you can see here, as what I told you, dekat carbon ni dia add hydrogen. Okay, dekat oksigen pula, you boleh nampak dia add another hydrogen atom. Okay. So that's why you will get a primary alcohol. Okay, kalau ketone, dia react with any of these common reducing agents. In this case, dia gunakan NaBH4 in the presence of methanol. Okay, so you can see daripada C double bond O, dia jadi C single bond O. And also at this carbon atom, dia add hydrogen. And at this oxygen atom, dia pun add another hydrogen atoms. Okay, so that's why I told you, dia add 2 hydrogen at the carbon and oxygen. Okay, so daripada C double bond O, dia akan jadi C single bond O, di mana dekat this carbon dia akan receive hydrogen, dekat oksigen ni pun dia akan dapat hydrogen. That's why dapat alkohol. Cumanya you have to remember, kalau aldehyde dia buat reduction reactions dapat primary alcohol. Kalau ketone dia buat reduction reactions, dia akan dapat secondary alcohol. Okay, so let's look at some of the examples here. Okay, kalau you ada carbonyl compound such as this is aldehyde. Okay, and then you nampak dia react dengan one of the common reducing agents such as NaBH4 methanol. So, apa yang berlaku? Site yang akan react adalah C double bond O, and you need to remember kalau dia buat reducing reactions with the reducing agents, kita akan add 2 hydrogen. Okay, satu dekat carbon, satu lagi dekat oxygen. Therefore, the product that will be formed is CH3, CH2, and then C single bond OH, CH, H. Okay. Tapi kalau you nak condensekan dia, nak cantik sikit, jadilah CH2. Nak cantik sikit jadilah CH2. Faham? Okay, so this is actually a primary alcohol. You kena ingatlah kalau aldehyde, okay, dia buat reduction reactions, kita akan dapat primary alcohol. How do you know that this is a primary alcohol? Because this carbon yang attached with OH adalah primary carbon. Okay, and this is actually a ketone. Okay, and then you see here, this is one of the common reducing agents, which is catalytic hydrogenation. This is the catalyst that ada hydrogen besides it. So, apa yang berlaku kat sini, this is a ketone, tapi bila dia buat reduction reaction, site yang akan terlibat ialah this C double bond O, di mana the carbon atom here akan dapat the hydrogen, oksigen pun akan dapat hydrogen. Okay, so you boleh tengoklah daripada C double bond O jadi C single bond O. Okay, and this is actually a ketone. Bila dia buat reduction reaction, you can see dia akan menghasilkan secondary alcohol. How do you know that this is a secondary alcohol? Because this carbon atom yang attached pada OH adalah secondary carbon. Okay, this is a secondary carbon because dia ada attached to another 2 carbon atoms. Okay.